Yeah, good morning, everyone. Today we are going to discuss about the remaining interview questions of VLSI DFT. The first question is simulation flow and difference between serial and parallel simulation. So simulation flow includes the defining objectives, setting up modules, running simulations, analyzing results, and making improvements. Serial simulation processes the task sequentially, while parallel simulation process the tasks concurrently. Parallel simulation can significantly, one second. Yeah. So parallel simulation can significantly reduce the simulation time compared to the serial simulation. Examples of parallel simulation include the running the multiple simulations on a different cores of a processor or using a cluster of computers for simulation tasks. Simply, we can say that parallel simulation will take less time. Within a single clock, we can able to load the data. We can able to with a single clock, we can able to unload the data. Okay, shift in, shift out, and capture is going to happen with the help of single clock pulses. In case of serial simulation, if your chain is having the 100 flops, for shift in, we require a 100 clock cycle. For shift out, we require 100 clock cycles for capturing one clock cycle. In case of parallel simulation, shift in one clock cycle, capture one clock cycle, and shift out another clock cycle. Next question is, how the mode signal for a boundary scan gets generated in jtag. The question is how the mode signal for a boundary scan cell gets generated in jtag. Yeah. So in jtag, the mode signal for a boundary scan cell is generated by the internal state machine within the tab controller. Mode signal is generated by the internal state machine within the tab controller, which is triggered by the combination of the TMS test mode select and TCK signals. Essentially, specific JTAG instruction being sent determines whether the boundary scan cells are active or not in test mode, active or not, effectively controlling the mode signal for the cells. Next question is, what is the significance of pass state of a tab in state machine? So, pass state. So, pass DR and pass IR. FSM passes its function here to wait for some external operation. The next question is, which instruction is having fix opcode in JTAG? Which instruction is having fix opcode in JTAG? In JTAG, the instruction with a fixed opcode is a bypass instruction. It always has an opcode consisting of all ones, regardless of the tab instruction register size. It always has an opcode consisting of all ones. In JTAG standard, the mandate that all JTAG devices must support the bypass instruction with the fixed opcode of all ones. So when bypass instruction is used, it is essentially connect the TDI pin directly to the TDO. TDI to TDO direct connection when bypass is enabled, allowing the data pass through without any processing within the device. So we can able to bypass all the all the circuits in the device. So useful for changing the devices. This instruction is particularly useful when testing a chain of multiple devices in a JTAG chain, as it enables you to bypass devices not currently being tested. Suppose if we have 5 devices, you want to test only third one, among the 5. So remaining you can bypass it using the bypass instruction code. So easy to identify. Due to its fixed opcode, bypass instruction is easily recognizable in a JTAG sequence. Next question is, why we give TDO value at the neg edge in the JTAG? So this is very important question. Why we give TDO value at a neg edge in the JTAG? In JTAG, the TDO test data output value is given at the falling edge of the clock TCK, because the internal state machine within the device is designed to capture and output data on the falling edge, allowing for proper timing and data synchronization during the shift operation. Essentially, the device latches the TDO value at the falling edge of the clock, masking it available for JTAG programmer to read on the next cycle. According to the JTAG, IEEE 1149.1 JTAG standard, TDO is always sampled on the falling edge of the clock. TDO test data output always sampled at the falling edge of the test clock. The internal state machine within the device is designed to update its output data at the falling edge of the clock, ensuring the data stability during the shift operation. During the shift operation, if you want to ensure the data stability, the TDO must be updated at the falling edge of the clock. So this is all about today's interview questions. So we'll meet our next video regarding the JTAG interview questions. Please share and subscribe my channel.